In this video, I want to tell you a little bit about something called percent concentration. We use percent concentration to quantify or put a number on the concentration of a solution in a way that's different from molarity. Hopefully by this time you've learned about molarity. You have a sense that molarity uses moles of solute and relates it to the volume of the solution. So moles of solute over liters, typically liters, of solution gives us molarity. So it's a relationship between solute and solution. Percent concentration isn't so different from that. It also has solute over solution, as you can see here in the equation on the screen. The difference is twofold, I guess. One, percent concentrations are found as a percentage. So when you divide, as always is the case, we take some fraction and take it times 100 to get it into percentage form. 5 over 10 gives us 0.5. We take it times 100 and we get a 50% of something. Well, in this case, solute over solution will give us some decimal or some fraction. We take it times 100 to get a percent concentration, as well as we do with percent calculations of all kinds. So that's one thing that's different. We have a times 100 in this equation that we don't have on a molarity calculation. The other thing that's a little different here is that instead of moles, we use a little bit more kind of comfortable or familiar unit for most people, and that's grams or milliliters of the solute on the top instead of moles. So we don't need to convert grams into moles. In fact, it turns out that we don't even have to know what the solute is to calculate percent concentration, because we don't need to calculate moles. We don't need to know what its formula is. We don't need to know its molar mass. We can just use grams of any old solute and treat it more or less the same, no matter what that might be. And the same is true for milliliters. So this numerator, solute, is in grams or milliliters of solute. We don't need to get it into moles. And in the denominator, we also use grams or milliliters. We don't use liters down here really ever at all. We use grams or milliliters as the unit in both the numerator and in the denominator. So we're working with a little bit smaller units in this calculation or in this equation than we were with molarity, where we're using things like liters. Here we're using milliliters as our denominator instead. So we're working with smaller quantities. One of the reasons for that is in the lab, when we're working with solutions or preparing solutions, we're not going to work with liters, several liters at a time. Most of the time we're working with a few milliliters, maybe 100, maybe a few hundred milliliters, but not necessarily several liters. And so it just sort of feels a little more comfortable typically to work with milliliters rather than to work with liters in our units with percent concentration. So that's our general equation. Now, you might look at that though and say, well, wait a second, if I can put grams or milliliters in the numerator, and I can put grams or milliliters in the denominator, doesn't that give me a lot of combinations? And you're right, it does. It actually gives us several combinations that do show up occasionally in different places, but the good news is we handle them all the same. All you have to do is pay attention to the units that are being used for the numerator and the denominator, and all it really affects is how you label your answer. Here are the three combinations that you'll see possibly show up in places that we find percent concentration involved with our work. Percent concentration, again on the top there, is solute over solution times 100. And in the bottom you see three sort of options for the units that might be used in the numerator and denominator of those terms. And the units or the label that we would put on the answer that we got from working out a calculation using that. So if we work here in the red, we have grams in our numerator and we have grams in our denominator. Those are both mass units. And so we would express that as a percent. And then on the numerator, we have a mass, so on the top here an M, and the denominator, we also have a mass in grams, so on the bottom an M. So we would describe this as a percentage mass over mass, or we would sort of suggest that we're dividing mass by mass to find this, and so we would describe this as a percent mass by mass, this first one here in red, percent mass by mass, dividing mass by mass. The second one in green would be if we had a mass of solute in the numerator and a volume in milliliters of solvent in the denominator. Since we have a mass over a volume, we're dividing mass by volume, we would label that answer then, if we use that green version, we would label it as percent mass over volume, or percent mass by volume, dividing mass by volume. And in the third choice, we have purple here. If we used volume on the top and volume in the bottom, milliliters of solute and milliliters of solution. This is common if we're dissolving a solution or preparing a solution using a liquid solute to make a liquid solution. It's easier typically with liquids, often is the case, to measure them in volume rather than to try to measure them in mass. And so if we take a volume of a solute and mix it to prepare a certain volume of solution, we would have a volume on the top and a volume on the bottom. And so we end up with a percent value, volume over volume. So percent V over V, dividing a volume by another volume to find that answer. So those are kind of our three common ways of calculating percent concentration. You'll notice there's one missing. We don't really ever have volume on the top and mass on the bottom. So that's the one of the four combinations that's left off of this group of three. And so you've only got three to contend with. But we'll work through some examples with the assignment that you've got, and work through a few examples that use different units and show you kind of, there's really not a lot of difference in how we handle these at all. We see quite a few mass over mass. The first one, we see quite a few volume over volume, especially with things like rubbing alcohol, where we work with a solution that's prepared using a liquid dissolved into water, and it's easiest to use volume over volume. I don't think we see quite as many mass by volumes, but they're out there. If you look around your house, you'll find there are lots of things in your everyday life that have concentrations shown on them. Things like toothpaste. If you look at your toothpaste, the next time you're brushing your teeth and you're trying to brush for 2 minutes like the dentist tells you to, take a look at the label on your toothpaste, and you'll almost certainly see that the concentration that's given is for the fluoride, for sodium fluoride, or the active ingredient fluoride in your toothpaste, which is important in building that tooth enamel up. It's going to tell you the percent concentration of your toothpaste of the fluoride that's in there. It's very small. It's like 0.24% or something, very, very small, the amount of fluoride that's in toothpaste. And that small amount is effective in making your tooth enamel stay strong and prevent tooth decay. So there's lots and lots of percent concentrations in everyday things you'll find in a bathroom, in a kitchen, a laundry room, cleaning supplies and chemicals, maybe even in your garage. Certain things are coming in concentrations. They're quite common all over the place. All right, so let's take a look at some examples from the assignment that you've got that should look like this, hopefully. And I'm just going to kind of go through a few different examples, kind of show you a few different ways to calculate finding percent. We could also find the amount of solute or the amount of solution. We can even find the amount of solvent in some of these problems as we go. And then work with various labels so you can kind of recognize that there are different labels, those mass by mass labels that we talked about, or mass over volume, or volume over volume as our third choice. So let's take a look right out of the gate here at 1A. It's going to ask us in number 1, there are several parts to number 1, to calculate the percent concentration for the following solution. So in the very first problem, they've given us 52 grams of solute in 160 milliliters of solution. Remember now, our formula in all of these problems will be solute in mass, grams or milliliters, over solution in mass in grams or volume in milliliters, times 100 gives us percent concentration. Okay, so that's our basic equation, solute over solution. And as long as we're working with units that are sort of either small, like grams and milliliters, or I suppose if we're working with larger units like kilograms and liters, which is very uncommon, we're good to go. We don't have to worry about getting things to moles. The units certainly don't have to match. It's perfectly okay if we have mass and volume in the same calculation. We just have a label for that at the end. Okay, so let's take a look at this. Here we've got 52 grams of solute. So in my equation, that's my numerator. 52 grams of solute in 160 milliliters of solution. And so if we look up here, we've got solute, we've got solution. We simply put those in and we're off to the races. 160 milliliters. Take that times 100 to get it into a percentage form. If you plug that into your calculator, divide it out, take it times 100, you should get 32.5%. The only thing that's left to do is to label that percentage. So we divided here a mass in grams on the top and a volume in milliliters on the bottom. So my units for percentage will be mass over volume. So you should finish out your label like that, 32.5%, and I divided a mass by a volume. Had we used a volume and a volume, we would have V over V, but the numbers would still be the same. So our number would be the same in our answer, just our label would be a little bit different. So there's lots of problems like that. Let's take a look down here at letter C. 40 milliliters of solute, and then it gives us 0.250 liters of solution. Milliliters and liters don't quite go together, right? Milliliters are small units, liters are larger units. And so we want to make sure those units match up. It's still going to be solute over solution. So I'll take 40 milliliters of solute and put that on the top. And then for solution, 2.25 liters. And you don't need to show these metric conversions, but if you feel like you need to, right, that's 1,000 milliliters for every liter. And so that's 250 milliliters of solution. So I put that on the bottom instead, 250 milliliters instead of 0.25 liters. That way those units, they kind of match up. They need to be in the same scale. And milliliters and liters are 3 powers of 10 apart. They're 1,000 times different in size. And so we want to make sure that they kind of go together, that they're compatible when we're calculating percent concentration. We could have converted those milliliters into liters, and we would have had liters over liters, and we'd had the same answer, it would be fine. But in this case, I went ahead with milliliters and milliliters just to kind of stay consistent. And if I calculate that, I'll have a concentration of 16%. And the label on that, since we used a volume on the top and a volume on the bottom, would be V over V. We don't use milliliters over milliliters, although that would seem like the same kind of thing, right? The reason is that V over V can be milliliters over milliliters, it can be liters over liters, it could even be gallons over gallons if you wanted to force it to be that way, or quarts over quarts. Any matching units of volume on the top and on the bottom would give us the same percent concentration if we were to work with them, and they're interchangeable with each other in that way as well. Okay, I'll leave B and D to you. They're kind of like the ones that we've done. I won't work through half the problems on here, but we'll look through an example of each from each section or so. It's kind of the idea. For part 2, it says calculate the mass or volume of solute. So we're looking for the top value in my concentration calculation. Solute over solution times 100 equals percent. And they're asking us for solute. So if I stick with that template, solute over solution, I'm looking for my solute. Calculate the mass or volume of the solute. In other words, on all of number 2, you're going to be looking for the numerator because that's where the solute goes. Calculate the mass or volume of solute for the following solutions. I have a 12.5 mass by volume solution with a volume of 650 milliliters. So I put that down the bottom. That's the solution that has a volume. So that's my volume of solution, not my solute. Right? Times 100 equals a concentration they gave us of 12.5%. As far as working out the calculation from here, okay, for number 2, we need to just solve for x, right? And essentially, if you want to go through the math of this, we're going to divide both sides by 100. That'll kind of get rid of that 100. So I can divide both sides by 100 here and 100 here, or you can do away with that step and simply write the percentage as a decimal, and then you don't need to show it as times 100 even from the start. But if I do that, this will cancel out, and I'll be left with what? X over 650, 650 equals 0.125, essentially over 1, right? And if I cross multiply, I'll have 1 times x equals x, and I'll have 650 times 0.125, and that gives me 81.3. Okay, when I solve for my x by cross multiplication, if I just cross multiply, I'll have x equals 81.3. What are the units on that? Remember, this was a mass by volume solution. So the numerator up here needs to be a mass, and the bottom we see in milliliters already is a volume. So we have a mass over volume. That means my x here needs to be in mass, and that mass then needs to be in grams. So 81.3 grams would be your answer. You could go a little further, say 81.3 grams of solute, just to kind of clarify exactly what you're talking about there. Now notice, on none of the problems that we've done, and in fact, none of the problems on this page, will you see what the solute is. It doesn't tell us if it's sugar or salt or ethanol or gasoline or any solute at all. So without even knowing what the solute is, we can do all these calculations. We couldn't do that if we had to turn these things into moles, because then we'd have a molar mass, or we'd have to figure out what that grams to moles or molar mass would be to make that conversion possible. Okay, let's take a look at number 3. Number 3 asks us to find the volume of the solution. So now we're switching over to where we're going to find the denominator instead of the numerator in our work. Okay, the volume of solution is the denominator. Solution's always in the bottom. So when you're asked for solution, that's going to be calculating something in the denominator of your work, or the denominator of your calculation. Which tells us then that they must be giving us the solute amount, and they must be giving us the percent. Those are the other parts of our equation. Sure enough, they are. They tell us that this solution contains 10 grams of solute, so that goes in my numerator. We don't know the volume of solution, so that goes in my denominator. I'm going to take this whole thing times 100. So solute on the top, 10 grams. Solution's volume on the bottom, we don't know. Times 100 gives me percent, and that percent is told here to be 8%. And it's a mass by volume solution concentration. And that makes sense because I can see here that I have a mass of 10 grams, and I know that the question's asking me for a volume of solution, so this bottom number down here will in fact be a volume when I get done calculating it, because this is an M over V concentration that we're working with. All right. If I go through the same process again of solving for x, I'll take this and divide both sides by 100, or just move it over into decimal form from the start. If I do that, I've got 10 over x equals 0.08. essentially over 1, right? Now be really careful. This is the point where we see a lot of students make a lot of mistakes in terms of solving for x. They think they can just kind of randomly multiply things and hope that x is going to just work out. Be careful that you don't do that. You want to cross multiply properly, okay? If we do that at this point in the problem, we'll have cross multiplying. I'll have 0.080x equals 10. Right? All I've done is cross multiply. And notice what I've done here too, I should mention, I've kind of dropped the units out of my work. And of course, it makes it a lot easier to, I think, navigate these problems if we drop the units. The only reason that I went ahead and did that was because I know that they're going to want me to find a volume at the end. And because I was given grams, that volume is going to be in milliliters. That's the matching unit that goes with grams, right? A mass by volume solution is grams over milliliters, like we talked about in the slide at the beginning of the video. So this is going to be milliliters for my denominator answer. I don't need to kind of navigate the units as I work through the problem if it makes my life a little bit easier. So at this point in the game, I would need to find x. I'm going to divide both sides by 0.080, pardon me. And when I do that, I'll have things canceled out here. X comes out to be, for number 3, 125 milliliters of solution, or just 125 milliliters for the volume of that solution. And you can always go back and check, right? If you're not comfortable with it at first, or if you want to just be real confident in your answer, go back and check. 10 divided by 125 times 100 should give you an 8% solution back again. As long as there isn't any major rounding in these problems, should be okay. Now, one little curveball to show you here on number 4. You got to watch. We've been paying most of our attention to the numbers, and we do that all the time. We tend to focus ourselves on the numbers and not care too much about the words in between, and that can catch us off guard. But notice what they've done here. They're giving us the solute, which is a noun that we've seen in the other problems, but then they're giving me water. And water, of course, isn't a solution. Water is a solvent. So this is the solvent. Now, where in my percent concentration equation is the solvent? You might look at the concentration equation that we started out with, and you might say, well, it's not there. And you're kind of right, and you're kind of not. Percentage is solute over solution, right, times 100, and that gives us percentage. I look at that equation and I don't see solvent in there, at least not right away, right? But if I know what I'm looking at, I can tell that this solution that's down here at the bottom, right, is made up of 2 things. This is, according to the definition that we took in our notes for solutions, oh, I'm sorry, I got excited about it there. That's solute plus solvent. That's the definition of a solution, kind of by the dictionary definition. Solute plus solvent makes solution. And we can say the same thing about it mathematically. The mass of the solute and the mass of the solution makes the mass of the the mass of the solute and the mass of the solvent makes the mass of the solution. And so if we can add up those 2 masses, we'll have the solution's mass. And it turns out that in this problem, that's kind of what we have to do, because they gave us a solute here, and they gave us a solvent in water. If we're going to fill these numbers into that equation, then we can't use 75 by itself, because that solvent doesn't exist alone in the equation. The solvent has to be combined with the solute and then be plugged in as the solution's mass down there in the denominator. So let's go ahead and do that. For our percent concentration in 4a, we want mass of solute, which is 25 grams. That's fine to use. 25 grams is solute. Divided by what's our mass of solution? Well, it's 25 grams for our solute, and then 75 grams for our solvent. So a total of 25 plus 75, a total of 100 grams of solution. Not 75, but 75 grams of water plus 25 grams of solute. So for example, if I filled a beaker with 75 grams of water, and then I added to it 25 grams of sugar and dissolved it, the solution wouldn't weigh 75 grams, right? The sugar's mass doesn't just vanish into thin air because I dissolved it. The sugar's mass is still there in the beaker. It hasn't vanished. It hasn't disappeared. It doesn't go away. It's just changed into a dissolved form. But the total mass would now be 100 grams. And the same sort of idea here comes through here. Of course, 25 over 100 times 100 gives us a pretty straightforward concentration of 25%. And then our units on that, because we used a mass and a mass, will be grams over grams, or our label, mass by mass. It's a 25% solution by mass. That's kind of how that works out. So be on the lookout for words like water, for solvent, and solution. And if you look at number 4, those terms all show up as you work through the rest of number 4. Okay. I'll help you with 6A, and then I'm going to stop and let you try the rest on your own. 6A asks us to find the mass of the solvent. So in the same way, I want to use that equation that we just used, that sort of extended equation, where the solvent's mass is kind of hiding down there in the denominator, right? The solvent itself isn't alone in this equation in blue. It's part of that solution's mass in the denominator. So if I want to find the solvent's mass, I have to find the solute's mass first and take it away from the solution's mass as a whole. So let's take a look at 6A and see if we can figure that out. Let's take our equation, solute over solution times 100 makes percent. Well, look at our problem. Do we know the solute's mass? I don't think so. We have solution, which has a mass of 150 grams. My solution's mass, I know, it's 150 grams. What else do I know? Times 100 gives me a 3% solution. So I have a 3% solution. What I don't know is X. What I don't know is the solute. Now, it's not asking me for solute, but remember, if I know the solute's mass, I can find the solvent's mass, because right down here in the bottom of this, in the denominator, that 150 grams of solution in question 6A is the solute, which we're about to find as X, plus the solvent, which we're going to need to find at the end to answer this question. So if we know the solute, we can take it away from 150 and get the solvent's mass just like that. All right, so forget the maroon down here in the bottom for just a moment. Let's finish out up here in red. Let's finish out and solve for X. Okay, so to do that, what we did on question part 2 up above, we divide both sides by 100. This will cancel out. I have X over 150 equals 0.03 over 1, right, essentially. If I cross multiply at that point, I'll have, if I cross multiply at that point, I'll have 1 times X, so X equals 150 times 0.03. Well, that's 4.5. And what is that X? Remember, it's up here in my numerator. It's the mass of solute. Remember, this is a mass by mass solution. So this is a mass in the numerator of 4.5 grams of solute. And this is why nouns are important. This isn't what the question asked me for. They want the solvent. However, I know then that if the solution's mass, which was given to us in this problem as 150 grams, right? If I know the solution's mass is 150, and if I know that 4.5 grams of that is the solute, which I can see down here in the bottom, the rest of that 150 must be the solvent's mass. And so if I kind of think about my definition from earlier, or my definition from back in the notes at the beginning of this unit, if I think about solution, pardon me, too many solu words, solution equals solute plus solvent, as sort of taking the definition from our notes and turning it into an equation, then I can say that 150 grams equals what we just calculated, 4.5 grams, plus the solvent, which is the part that we're interested in here for question 6, right? And then to solve it, I simply subtract 4.5 grams from both sides to get that solvent on its own. And what I'll come up with then is solvent equals 145.5 grams. That's my solvent's mass, 145.5, and then the solute adds in the last 4.5 for a total of 150. So my solvent's mass on question 6A, kind of in a roundabout way then, is 145.5 grams. Hopefully that makes sense. Those are about as complicated as these questions on percent concentration will get. Work on the rest of the questions that are on this page, and then follow the instructions that you're given as far as when that's due and how you should turn that in. All right? If you have other questions, stop in and talk to me during office hours. I will visit with you then. Thanks for listening. Have a great day.